So now that you've had a chance to look at some of this data, I want to talk about some of the similarities and differences between these three graphs. So let's first start looking at the stem and leaf. Now, in the stem and leaf, just as a reminder, the stem over here represents our tens place, and the leaf represents our ones place. Basically, what that means is if I was looking for the smallest number in my data set, notice I have zero tens up here, five ones, so that's just the number five. If I wanted the biggest number, I would go to my tens of seven. Seven tens would be the most, and one one, which would be seven tens and one one, would be 71. That basically means that on one day, only five chocolate bars were sold, and on another day, the best day, there were 71 chocolate bars sold. Now, you're going to notice in all up here, we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data because there were 14 days. Therefore, we have 14 different pieces of data in our chart. Now, one nice thing about the stem and leaf chart is that we know exactly what all 14 numbers are. So we know exactly on one day only one chocolate bar was sold. We know on one day 71 chocolate bars were sold. If we look down here, we know one day 60, on 2 days, it looks like 63 chocolate bars were sold, and so forth. So we know that information exactly. One downfall is we don't know which day that happened. So, for instance, maybe day one was five chocolate bars sold. Maybe day one was 71 chocolate bars sold. The reason that's kind of important is because we want to see if there's any sort of pattern. Like, did they start off only selling five and then they got better over a course of time? Or did they start off selling 71 and then get worse? That would make a big difference in our data, and we would want to know that to tell the true story of our data. So a stem and leaf chart does give us all the numbers exactly, but it may not tell us the order, and the order does kind of matter in this case. All right. So our second chart here, again, is going to be our line plot. Now, for line plots, we can get down there. Uh, some line plots are a little different than this, and we'll talk about that in just a second. This particular line plot is giving us a range. So again, it's saying from 0 to 20, from 21 to 40, from 41 to 60, from 61 to 80, 81 to 100. Now, this is telling me that because of there are nine X's here, there are 9 days that are in between 61 and 80. There are 4 days that are in between 41 and 60, and there's one day in between 0 and 20. If I take one day, 4 days, and 9 days, if I were to add those three numbers together, I would get 14 days, which is how many pieces of data that we have. Now, it is nice to be able to see it this way because we can see, oh, well, on nine of the days, which is most of the days, they actually did pretty good. They sold between 61 and 80 chocolate bars. And it also shows us that they did have one bad day. That one bad day is our outlier. It's something happened that day that we don't know about that kind of made them not sell very many chocolate bars. Now, the biggest downfall here, especially when we're dealing with these ranges of like 61 to 80, is we know there's 9 days between 61 and 80, but we don't know exact numbers. Were they all 61? Were they all closer to 61? Were they all closer to 80? Was it mixed all up? We don't really know. So it's nice to be able to see this as a representation, but it's really hard to get exact numbers. All right. And then if you remember, our third graph here is a, go down, is our line graph. Um, just a couple things about the line graph to start is you'll notice across the bottom here, we call this the x-axis. It's measuring days over the next 2 weeks. So you'll notice it goes all the way to 14 because there are 14 days in 2 weeks. Along that horizontal axis, when we're looking at a line graph, it's usually going to be measuring time. So it could be time in minutes, time in hours, time in days, time in weeks, years, centuries, whatever you want it to be. But the x-axis usually measures time. Here it's measuring in days. Um, we also have what we call the y-axis, which is up here. And the y-axis is what we're measuring, which is the number of chocolate bars sold. So we're measuring the number of chocolate bars sold each day. Now, one thing we can point out here is throughout this graph, we can look at how many chocolate bars are sold by looking at our peaks and our dots here, right? So if you look all the way across, notice we have 14 different dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14 would be at the end. So we have all of our data here, and it's telling us on particular days how many chocolate bars were sold. Now, one really nice thing here that I think it stands out more than any graph is it helps us to see the outlier here. This is a big difference. This is a big change. This is one of those places where we would be asking ourselves, what in the world happened there? Something big happened there. It decreased by a whole lot. What is going on? That's easier to see because it's a picture representation. The other thing is to see is we can see whether like over time we're getting better or we're getting worse or we're staying about the same. That's easier to see because we know exactly, for instance, if I wanted to go exactly to day two, I know that's the number that it is. It's just a little bigger than 60. And I can say, well, that happened on day two. And I can say, well, down here at day 10, it really got bad. What happened at day 10? The biggest downfall of the line graph sometimes is because over here, notice, I'll give you an example here. This goes between 70 and 80. Sometimes it's hard to see where it stops. So sometimes you're guessing a little bit. So for instance, if I looked at this last data point here, it looks like it's between 60 and 70. Is it in the middle exactly? I don't know. It could be 64, it could be 65, it could be 66, it could be 63. So I don't know exactly, but I know pretty close where it is. So that's the thing. We don't have exact numbers, maybe, but we do know which day something happened on. So just as one quick review, we have our line graph, we have our line plot, and we have our stem and leaf. All three of these are representing the same data. They're doing it in three different ways. One last thing I do want to point out about the line plot really fast. If I can get down. One last thing I want to point out about the line plot is a lot of times, and I didn't make this line plot here because my range was actually so big, but a lot of times on a line plot, you'll see across the bottom there won't be ranges, but rather it'll just say like 1, 2, 3, 4, 5, 6. And let's say there was a day where they sold 4 chocolate bars. Let's say there was a day where they sold 3 days where they sold 5 chocolate bars, or 2 days where they sold 2 chocolate bars. A lot of line plots look more like this without this range at the bottom, which might change how you feel about a line plot if it looks like that. Again, the reason I didn't do that here is because we were going all the way from a small number between 0 to 20, all the way from a number between 61 to 80, so that would have been really big. But just keep in mind a line plot can also look like that.